G'day gamers, and welcome to part 2 of our room transition tutorial. In this tutorial, we're going to cover the transition to make it similar to what Gauntlet uses, where the player spins around before exiting the level. At the moment, we've just got a quick snap where it goes to the next level, but I'd like to add some polish to make that look better. We'll also need to fix some things in regards to the enemies and how they interact with the player, because the player is actually at the exit for a longer period of time. Now, we left the last tutorial with 2 rooms. I've gone ahead and added 2 more. So we've got the existing initial room, and you can see I've added the floor marks as well, which is just a random selection of these floor marks on the floor marks layer. And I've also made sure we have the shadow. So for level 2, which we covered in the last tutorial, the same thing. We've got the floor marks and we've got our shadow. And for level 3, I've made it a smaller level, so I've changed the width and the height down here, and the player starts just here, and they have to make their way to the exit over here. So the same thing, we've got our floor marks and our shadow. And lastly, we have level 4, which is a bigger room. Again, the player starts over here, and they have to travel through to the exit here. Now at the moment, this exit should just take them back to level 1. And if we just check with our level 2, remember I had multiple exits. So this one takes you to 3, this one takes you to 4. So by having the target room in the instance, that enables us to have multiple exits or different locations from the one room. This one goes just to level 4. And when you create a new room, you need to go to the creation code and to that set level info function. And in there, you need to set the player's start position and the enemies and even the spawn chance per tile. So here's my level 3 and here's my level 4. So the animation I want to work towards looks like this. The player touches the exit and then move to the center of the exit. They spin around and then we have a transition which takes us to the next room. So to start with, let's try to get the player moving towards the middle of the exit. And we're going to use another state for that, an exit state. And then inside that state, we're going to have a sub-state. And that will then enable us to control what's happening with the player at each step of the transition. So to start off, let's set up the sub-state we're going to use in that exit state. So if we go to our macros. So just here, we're going to add another enum called sub-states. And the value of substate is going to be either a center, where the player moves to the center during the transition, and we're also going to have a wait substate. Now we also need an exit state for our normal states. So the player will be in the exit state, and within the exit state, we'll have some substates which lets us control what's happening to the player. Now the variable that controls what state we are in is called state. So we need a variable as well called substate, which will control what substate we are in. So let's go to the player. And down the bottom, I'm going to add these variables. So we have a substate variable, which will set the substates.center. And we have an exit wait time, and that's the time we're going to wait at the exit. We also have a target X and a target Y, and these will be the X and Y position to move to when we are exiting. So we'll set those values to the middle of the exit tile, and that way the player will move towards that position. So back in the player, we need to have another state within our step event. So down here, let's just do this after our knockout state. So we'll need another case. And this will be our state.exit. Now, under this state, we're going to have another switch statement. And here we will look at what substate we are in. And we add another case, and we can be in substates.center. Or we can be in substates.wait. So while we are in the exit state, we can be in a different substate, and that will allow us to control what's happening to the player while they're exiting. So just under center, I'm going to paste this. So here we're moving towards that target X, target Y position, and that's going to be the center of our exit tile. We will get those values in a moment, and we're just moving there at 1 pixel per step. Then we're getting our distance to our target position, and we're checking if that distance is less than 2. And if it is, well, that means we're close enough to the target position. Let's set our position to that target position. Let's stop moving. Let's move to the wait substate, and we'll do that for this amount of time. Now let's go look at our wait state, and I'm going to paste this. So when we're in the wait state, what we're doing is taking 1 off exit wait time per step, and we do that with this minus. And if the value is less than or equal to 0, then we are going into the idle state, and we're moving to our target room. Now remember, target room is a variable inside the exit. It's not in the player. So we'll need to move that variable over to the player when we touch the exit. So if we look at our player and we have a collision with the exit here, at the moment, we're just teleporting straight to that target room of the exit. But instead of that, I'm going to delete that, and I'm going to replace it with this. So when the player touches the exit sign, we will check if they're already in the exit state, and if they are, then we don't run any of this code. But if they're not, then we move them to their exit state, we move their substate to center, and we get the center positions of the exit. And we can do that by saying other.x plus ts divided by 2, which is the tile size. And because we know this exit is the size of a tile, it's actually finding the middle of the exit tile. And we're also setting the target room to the variable from exit, which is the target room variable. So the player now knows what room they need to go to. Now I've already showed you some other levels, and there's no shortcut to the exit sign, so you'd have to run through the level in order to test it. But when you want to test your own game, it's really handy to add dev shortcuts. And these allow you to basically cheat and test certain aspects of your game really quickly. For example, here we could add a cheat that allows you to hold the F1 key and then click anywhere to teleport your player to that position. It's very handy for moving around your level quickly. So if you want to add something like that, you can go to Yoyo Games. And just in the create event, let's just add a variable here, and we'll piggyback on top of this global variable set. And I'm going to call it dev mode. And we'll set it to true to start with. So the variable is global.devMode. And then inside of Yoyo Games, I'm going to add a begin step event. And the reason I'm adding it here is I don't want the player to be able to press the mouse button and fire when you're holding the F1 key, because that means you're trying to do your dev mode test and we don't want the player to fire at the same time. So by putting it here, this will happen before the player can get a chance to run their step event. If we put it in the step event of Yoyo Games, there's no way to know which step event is going to run. Even though you could have Yoyo Games being created before the player, there's no way to know if that's actually going to occur when the game runs. They don't give you a method to control which step events go in which order. But they do give you a begin step event, and that's to solve that kind of problem. So inside here, I'm going to add this code. So we're looking if our dev mode is on, and if it is, if we're holding down F1 and we press the mouse button, this applied to is in relation to the player. So we set the player's position to the mouse position, and we set their can attack to be false. And I set this alarm as well so that the can attack will be reset. And that'll stop them being able to fire when you teleport around. So under this global dev mode, you could add any of your other dev mode shortcuts. And then when you want others to play your game, you simply set dev mode to be false and they'll all be disabled. So let's press play and test the game. So now I can hold down F1 if I don't want to move around, and I can teleport instantly to the new position. And what happened was we moved to the center of the exit, and then we teleported to the new room after we waited 30 steps. So that works great. So instead of running to the other exit, we can once again hold F1 and we can jump around very quickly. And we can test the exit over here. Now, you saw then that if we are on the exit sign, the enemies can attack us. So that's not ideal. We can quickly jump around here, test this out. And here, if we just touch, we'll see the player's also running when they're touching the exit. So all of that works really well. But there's a few things that we need to fix. So the player continues to run when they are in the exit state. So let's fix that first. So let's go to OPlayer. And just in our step event here, the reason they're running is because that's the last animation state they were set to. So in our exit state, we need to add this anim script. So I'll take a copy of that and just here, we'll paste it down the bottom. Now we need to go to that and we need to set something for when we are in the dead state. So instead of being in the walk animation, I think it'd be better if they were just in idle. So here's where we are dead. Let's take a copy of that and paste. And instead of dead, we'll call this exit. And we'll just set it to the idle animation. Now, a few more things we need to clean up. Firstly, the player can still be attacked and damaged while exiting. So let's fix that by adding a new function. And just under our scripts, I'm going to create a script or a function called isDamageable. Now we can use that to first check if an entity is in a state in which they can be damaged before we try to damage them. And this kind of function is really useful when you have states where the player can move to them and not be damaged. You just put the state within this function and you don't have to do anything else. So you could look at it as future-proofing your game later when you want to have a state that does this. You have the ability to do it very quickly. So inside here, I'm going to add this. So our function will return true if the past entity ID is in a state in which it can be damaged. So when we call this, we'll pass the ID of the instance we want to check, and we'll look at the state of that instance. So this could be an enemy or a player. And by default, we'll return true. So we'll say that it can be damaged. But if we have a case where they're in an exit state, a dead state, or a dash state, they are all states where they shouldn't be damaged. So we'll return false. Now in Visual, you have to separate your cases even if you want to return the same value. But in GML, you can write the cases one after the other. Now, how do we use this? Well, everywhere we damage entities, we just run this check beforehand. So if we look at our damage entity function, we already exclude dead and dash states. So instead of doing that, let's just check if isDamageable returns true. So instead of all of that, let's just say if we are not isDamageable, and we're looking at the ID because that's the ID of the instance that we're in at the moment. So if isDamageable returns true, that means it can be damaged. But if it returns false, that's why we put the not there, because the true will mean we'll exit the damage entity function and we won't damage this entity because it's not in a damageable state. So we also should check when the enemy hitbox hits the player. So if we look at our entities and look at our enemy, we have an enemy hitbox here. And right here where it hits the player, I'm just going to add this. So before we actually run damage entity and before we run any of this, we check if the other is damageable, which is the player. And if it's not damageable, then we want to exit. Because if it is damageable, well, then we want to do all of this. But if it's not, we just process the exit. And I know we already checked this in damage entity, but if we don't do this, we're going to get the sound still happening, even though they're not damageable. So let's take a copy of this. And let's also look at the explosion. So just in here under explosion, and where we hit an entity, we just need to add this line up the top. Now, the only other place where we do damage is in the arrow for the player and where the arrow hits an enemy. Now, we already cater for this by checking that the enemy has HP greater than 0, but we may add a state later where the enemy can't be damaged even though they have HP greater than 0. So instead of this, let's actually use our is damageable, and we want to check the other, which is the enemy in the collision. And if damageable other is equal to true, then we can go ahead and damage the enemy. Now, we can test this by throwing bombs on the exit. And there we go. We were standing on the exit and we didn't get damaged. So we could also test this by having the enemy hit us just as we exit. And we don't get damaged like that either. Now, the other thing you might have noticed is the enemies can walk all over the exit. I'd prefer if they pathed around it instead of walking on it. And this kind of thing can come up in other parts of your game when you want an area enemies cannot go, but the player can. And you have something you can shoot over, like a chasm or a gap in the tiles. And I'll show you a method that you can use to solve these problems. So if we go to room 1, and let's add a solid over top of this exit tile. And let's go to our O game and go to our room start event. So just down the bottom, right here after we're setting the player's start position, I'm going to add this code. So what we're doing here is we're using with or apply to look at all of the O exit instances. And we're creating a solid on top of that instance to stop the enemies walking on it. So here we're creating the solid, and I'm creating it 2 pixels offset from the top left of O exit because the origin's up the top left. So I'm leaving a 2 pixel gap on the top and on the left. And I'm doing that because the player needs to be able to interact with O exit. And if there's a solid over top of it, well, they won't be able to touch it. But I'm leaving a gap so the player can actually touch the O exit instance. Now, moving it 2 pixels off creates a 2 pixel gap up the top and on the left. But on the right, we're actually 2 pixels over, and on the bottom, 2 pixels over, because the solid object is the same size as the exit object. So in order to also move the right and the bottom 2 pixels up, I'm then setting the horizontal scale of the inst, which is the solid, to be 1 minus 4 divided by 32. The tile size is 32. So this will set the solid to be 2 pixels smaller than the exit tile on the right and the bottom. Now, the last thing I'm doing is adding that cell, which is the X and Y div TS. So that'll give us the actual cell location, and we're adding that to the MP grid. This will stop the enemies being able to path through it, and this will stop the enemies being knocked into it. For example, if you're an explosion or the player shooting them, they won't be able to interact with it. And making it smaller will allow the player to interact with it. So let's press play and test that out. So we have our tile. You can see it's 2 pixels bigger than the solid that's underneath. And if we touch it, well, we actually get stuck. Even though we can interact with OExit, the problem is OExit is trying to move us to the center of this tile. But the solid that we created is stopping the player from moving. So we need a way to turn off our collisions for particular states. But we can change the collision in OEntityParent to only work for states when we want it to. So if we look at our OEntityParent and we look at our collision with a solid, now remember this is for the player and the enemy, we just run the collision script no matter what state they are in. But let's change that and let's make it look like this. So now what happens is by default, we run the collision script. But if we're in the exit state, we run no collision script. So let's press play and see if that makes a difference. Now you also notice that our projectiles can no longer go through the exit or over the top of the exit, and our bomb also just bounces off the exit. Now you want the player to be able to shoot over that or throw their bomb over that, so let's go and fix that as well. If we go to our OSolid, let's go to the create event, and in here I'm going to add a new variable, and I'm just going to call it allow projectiles, and I'll set it to false. And then back in OGame, where we are creating the solid, we can add this, and this is the assigned variable for the inst, and we're going to allow projectiles, set it to true for that solid. Now, how does that help? Well, if we go to our O arrow and we look at our solid collision with the arrow, we can add this. And what that will do is look at the allow projectiles of OSolid, and if that is set to true, then we just exit. We don't allow the arrow to be destroyed like we do for a wall. So suddenly we have a solid that can allow projectiles through it. Now we need to do the same for the bomb. So let's take a copy of this. And with our collision, let's just add that here. Now, the other thing to check is when we create a solid like that, we need to ensure enemies don't spawn on this tile. So back in our OGame, and up here where we are creating the enemies. So after we've found a spawn location, we need to do a check and say, is this spawn location on an exit? And if it is, then we don't want to go ahead and do any more checks. So just after this, I'm going to add this. And what collision point will do is check against the OExit object at that X and Y position, and it'll return the ID of any OExits that it finds. And it'll store that in the inst variable. If it doesn't find an OExit instance, then inst will be set to no one. And if you're using GML, instance position will do the same thing. It'll check at this location, and it'll check for this object, and it'll return the ID of the object that it found at that location, or it'll return no one. So down here where we're checking if the distance is greater than 128, we can also check if inst is equal to no one. And if it is, then we want to go ahead and create the enemy. If not, we won't do any of that, and we'll just go ahead and check the next tile. So just back in solid, let's just turn visible to be off, and let's press F5 and test it out. So now when we shoot, we go straight through the exit, but the enemies can't be pushed through it or path through it, and our bombs also go through it. So now that we have it working, I'd like to add an additional effect like the original Gauntlet, which has the player rotating around like they are being sucked into the exit. They animated a rotating sprite, but instead we'll just spin our character. So this is the kind of thing we're going for. So when they touch the exit, they move to the center, and then they start to spin and slowly get smaller as they're sucked into the exit. So let's go to our player. And let's go to the step event. And here where we go to the wait state, instead of doing that, we can go to another substate and then start doing that rotation. So over in our macros, let's add another one here, and I'm going to call it spin. Back in our player, let's add another state here. So we have our center state, and we also have our substates dot spin. And for the spin, I'm going to add this. So what we're doing here is using a function called max, and that'll take two values and it'll output the value that is the largest. And we're setting the output of that to our spin angle. So we're setting spin angle to be a value that'll be no less than -20. So spin angle starts at 0 and we're slowly decreasing it. But when it gets less than -20, we no longer output that side. We just choose the max, which is -20. So this could be lower than -20, but it doesn't matter. Spin angle will always be -20. And you can do this so that it'll start to spin. And once it reaches that -20, it'll only spin at that speed. Now we add that spin angle to the angle of our sprite. Now this will be a variable that we create. I'm not using image angle here because image angle changes the mask. I don't want to change the mask. I just want to change what we see of the sprite. Now down here, are we nearing our max spin angle? Are we getting near -20? If so, then we'll start to decrease our size. And we're setting the horizontal scale to be relative -0.03. So we're slowly shrinking the sprite size. And I'm setting the vertical scale to be image X scale. And that's actually the name of the horizontal scale. And I've done that here to show that we're then actually looking at that image X scale value. And when it's less than or equal to 0, it means we can't see that sprite anymore. So then we can go to the wait state. So let's go to the create event for the player. So we have a spin angle, and this is just the angle we will spin at when exiting. And we also need to add the angle variable, but we don't add it in the player. We need to add that in the entity parent because we're going to change the draw, and the draw is used by the entity parent. So just in the create event, and just down the bottom here, I'm going to add this. And it's just the angle we draw the sprite at. So now we have that value. We need to add these things into our draw event, and that's done in the entity parent under draw. So we have draw here. So instead of scale X using facing, we want to now use facing times image X scale, and that'll incorporate any scaling we apply to the image. So instead of scale Y, we can just use image Y scale. And for our rotation, we're just using angle. So this also happens down here as well. So make sure we just change both. So the only other thing to do is back in our player, we need to go to that spin state instead of going to the wait state. So just here in our center, once we get to the center, we don't want to go to wait anymore. We want to go to spin. So let's press F5 and test it out. And it looks good, but did it quite work? Maybe not. But the animation here looks great. It's doing everything that we wanted to do. There's a few things we need to change. So we need to hide the bow and also set the player's scale to 1 again when we move to the new level. So we can just add a variable here, and we can just say my bow dot visible is equal to false. And that'll hide the bow after we've moved to the center. Now, after we transition to the new room, right here, we go to idle and we go to the target room. At that point, we want to make the bow visible and the player also set their scale back to 1. And we also should reset our angle and our spin angle. So just here, I'm going to add this. So here we set the bow's visibility to be true, set our angle to 0, our spin angle to 0, and our image X scale and image Y scale back to 1. Now using these kind of variables will get you more used to using GML. If you don't like this and would prefer to use specific visual code blocks, you could use something like this. And here we're looking at my bow and we're setting its visibility to be true. We're setting the scale of the player to be 1 for the horizontal and vertical, and we're setting the angle and the spin angle. Now this is the same as doing this. So it's up to you what you use. I prefer to write them like this because it just seems like it's easier to see what's happening and it's quicker to do this kind of coding. You're still using visual, but you're starting to understand more about how to set instant variables of other objects. And you're getting to know about the names that Gamemaker uses for various parts of the object. So I'm just going to get rid of these. and I'm going to keep it at this one, but you can use whatever you like. Now, the last thing to do is to hide the shadow and also the health bar when we're in the exit state. So if we go to O Player and go to our draw event, now up the top where we are drawing the shadow, we can just add this. And now we're checking if we're not in the exit state, then we can draw the shadow. Now for the health bar to not show up when we're doing our exit, we can go to our show health bar function. And just here where we're doing a few checks, let's add another check in here and just say if state does not equal states.exit. And that's probably the easiest way for that to happen. So now we have a really cool effect. If you wanted to keep adding features, you could also add a room transition like the one I show in this tutorial video. And then you can even add visual effects and some sound effects. If you're a Patreon member, I'll upload this completed project to the Patreon site so you can grab the source code and see how I did those extra cool effects. Patreon members get access to all of my source code for all my videos, as well as any bonus features I add. For example, I recently upgraded the AI so they follow the player in a more natural way, spreading out as they chase, and also much more efficient with how they chase. This additional code is available to Patreon members on the site, so if you wanted to show your appreciation for anything you've learned from my tutorials, or just wanted the additional content, head over to Patreon and subscribe. Also, I still update my Udemy courses to ensure they are compatible with the latest Gamemaker. So if you want to learn more about Gamemaker, head to Slyddar.com and grab a coupon code so you can get a massive discount off the retail price of those courses over on Udemy. Well, that's it for now. Thanks for joining me. I'll talk to you in the next one.